So guys, now we will move to plate from the plate type freshwater generator to the shell and tube type freshwater generator. This is Sasakura Engineering Company shell and tube type freshwater generator. Not very common. You find mostly the plate type ones, alpha level ones, but these also are there. Some of the vessels, if you see the photograph, this looks like this.
To every marine engineer out there, from junior engineer to chief engineer and electrical officer, we all know that earning respect on ship is very important. We all know fast promotions are very important, and we all know that इज्जत कमानी है, promotion चाहिए तो काम आना चाहिए, तो जूते पड़ते हैं, गालियां पड़ती हैं, and for that you need a good mentor. Sometimes we keep finding those mentors on board ship, अगर नहीं मिल रहे तो MNDFLIX है ना, Merchant Navy Decoded has launched a subscription model where you can find more than 30 plus courses with respect to your rank, helping you earn respect on ship. Please enroll on these free trial videos, watch these videos as per rank, and then decide whether you want to invest or not, with a very good flexible payment plan as well. Jai Hind, Jai Bharat, Jai Mata.
Shell and tube type freshwater generator. This is your condenser section, this is the evaporator section, and the working principle is same, the vacuum distillation principle. This is the eductor here, but little bit the lines are different, something is different, but mostly the concept is almost same that we have already seen in the previous section. So I'll directly jump into the line diagram just little bit. This is a tubular type, model is KE30. So KE is the model. There are three different models for the Sasakura type of freshwater generator. Generally the KE ones are installed. The capacity is 30 tons per day. Salinity you can see a little bit higher over here, 5 ppm. They have say maximum salinity. 2 ppm was there in the plate type ones. Seawater temperature, as always, 32 degrees centigrade they have kept standard for the condenser. Inlet and outlet they have said almost 10 degrees difference, same as that in the plate type. So when the difference is more than 10 degrees, then it is a problem. Okay, so when the difference is less than 10 degrees, so that means the water did not get heated up. So more or less, if the 10 degrees potential is not maintained between the two, you have to be a little bit cautious that there is some issues. Okay. Then jacket cooling water 80 degrees, 70 degrees. Here also almost 10 degrees gradient is there. Jacket cooling water flow is 68.5 here. Maximum pressure loss is 3, same as the plate type. Other like condenser design pressure is 0.3 bar. Heater pressure is 0.3 bar. Evaporator design pressure is 1 bar. Okay, 3 bar, 0.3, 3 and 1. Okay, distillate pump pressure is here 2.5 meter cube per hour. Head is 30 meter aqueous, that means 3 bar pressure. Rest is about the materials and all discussed. Cast bronze, deflector is fiberglass. That is all about the details. Okay, now let us go into the diagram. So this is the line diagram that I have to discuss, and this is the most important. If you understand this, you are able to understand this kind of freshwater generator. So let us go and understand this line diagram. So you see, where do you start from here? You start from the seawater supply. So this is the seawater side. This is my filter strainer. This is the ejector pump. They have said that it has to be fitted below the load line. Okay, so on the bottom platform you will find at the bottommost part. Okay, always to be fitted below the load lines so that the head on this side is not more. Okay, this is the sea side. This is the ejector pump. You have got a compound gauge over here. Why compound gauge on the suction side? Stands for compound gauge. Why compound gauge? Say this filter gets choked or this valve is closed. There will be a negative pressure. So the negative pressure, it ranges from -1 bar to 4 bar. can see minus 0.1 to 0.4 megapascal. So if the filter gets choked, here only you will come to know the suction pressure will be negative. If the suction valve is closed or something like that, this will be negative. So there is no valve in this line here, it's just directly, there must be a valve over here. In the discharge valve, it's a pressure gauge, so it is plus pressure always 0 to 4 kg. Centrifugal pump, ejector pump. From here the line goes, this is one more pressure gauge over here just before the ejector, how much is the pressure inlet to the ejector. So the difference is in the plate type freshwater generator, the water returning from the evaporator feed line goes into the ejector or the ejector, but here the line starts from the ejector itself. You can see the water goes from the ejector, the jet velocities will be higher over here. Okay, it's around 4 bar pressure in the ejector in this case. So from the ejector the water is going into the condenser. If you see the photograph here, so this is the ejector pump line. From here it is going into the freshwater generator condenser like this. Okay, so this is your inlet line and this is your brine induction line. Okay, so from here the water goes into the condenser side. Here is a temperature gauge, so this is the inlet temperature T3. You can see it is from 0 to 100 degrees centigrade. This temperature is the inlet temperature to the condenser, which we had seen, it's almost 32 degrees centigrade standard they have given. Outlet to from the condenser is this T2. So from this they are showing this is passing through the condenser tubes and then it is going into the outlet side. So this is the T2. So it is also 0 to 100 degrees centigrade. You have seen there must be 10 degrees. So if it's 32 here, it should be around 42 or less than that. Okay, it should be around 42 degrees centigrade. 10 degrees difference or gradient should be there. If there is less difference, that means water is not cooling out over here. That means the passage is dirty or choke. Okay, then is your compound gauge. One compound gauge is given over here. Okay, so this pressure is shown minus 0.1 to 0.4 because this line is also going to overboard valve. This adjust this valve so that the feed water pressure can be within the green zone. Adjust this valve so that the feed water pressure can be within the green zone, that is 0.4 to 0.6 bar. The valve is to be installed near the distillate plant for easy operation adjustment. So there is a valve given here to adjust the back pressure and adjust the feed water line. And which is the feed water line? This is the feed water line. And let me check what the color, red one. Okay, which is the feed water line? This line. So from the outlet of the condenser, in the previous plate type also, from the outlet of the condenser the line was going into the evaporator. Here also from the outlet side it is going to the evaporators. So this line, this is a preheater. It is called a preheater. Why? Because steam will be going over here on the top. So there has been a coil to increase the temperature through this feed water preheater. When it passes through these tubes, so if you adjust or throttle this valve, back pressure valve, what will happen? This line pressure will increase. No, this line pressure will increase. So you can adjust. There is a green zone mark, green mark on this. Okay, so that the feed water pressure where you will find it in this line. This is the line and you will find the pressure gauge, compound gauge over here. This is the green mark. You have a green mark on this compound gauge that is showing around 0.4 to 0.6 bar. Okay, so this is your feed water line. coming out. So if you throttle this valve, this overboard valve, the pressure in this line will increase. Okay, so and then it goes overboard. There is always a back pressure. Maximum back pressure can be 8 meter aqueous, that means 0.8 bar, and minimum should be 0.1 bar. So it enters at a very lower part and exits at a higher section. You see, it's exit here. 0.8 bar back pressure. If you adjust or throttle this valve, your feed water pressure should increase. Should be in the green mark, always this one. Okay, so now you see this is the feed line from the condenser outlet. This is the feed water line going into the freshwater generator evaporator. Now you see here in this one you don't have a pressure regulating valve, because they have given the pressure to be regulated through this valve. Okay, in the alpha level model plate type, you had one spring loaded pressure regulating valve just on the inlet to the evaporator. Here you have to adjust this one to make sure that the pressure in the inlet is appropriate over here. That will be controlling the flow. Then you have got a orifice. Orifice is common over here also. So at the orifice, the pressure is given at the compound gauge. So at the orifice, there is a definite size of the orifice through which the amount of feed water is controlled. Okay, flow of feed water is controlled at this orifice, and velocity increases. And so pressure reduces, velocity increases, flow is controlled, and then it enters into the evaporator. One important point to note over here is, similarly as in the previous section, when the vacuum is increasing over here, pressure is dropping, you have got a magnetic pump over here. Pump line is connected over here through a spring loaded valve. This is the spring loaded valve. You can see it is noted over here, check valve with spring, so that it does not return back. Only line is from this way. There should be no line returning back to the chemical injection. This is the injection unit, check valve with spring. You can see this is the check valve with spring over here. So from this, the magnetic pump is going into the heater. Okay, into the heater over here. Now next is, after into the heater, you have got water going in, and this is the valve V3 given to, if you want to empty that empty line. This is the drain. If you see, it's a drain line or opening line. Okay, you can remove the water from this section by this valve. Okay, there is a valve fitted over here to end and at the end connection. This is the jacket water line, inlet and outlet, hot water inlet, outlet. Some model you will have steam also, can be steam also there. This valve V5 has been fitted to empty this cell, fresh water. Okay, this is the jacket water line going inside and coming out. There are two temperature gauges to indicate the jacket water temperature, inlet and outlet temperature. Okay, now that as the steam will be forming over here, it will going to the top sides. So like you had the separator part in the plate type, you have got a deflector over here. The purpose of the deflector is same as that of the separator, that whatever steam goes, it has to cross through this flow, through this deflector and then go up. Otherwise, steam will be directly carrying over to the demister. So this deflector basically deflects the heavy steam with salt into the seaside. Okay, and this is my side glass through which I can identify how much is the level of the brine. Okay, through this it is going up, and then from the demister again salt is removed. Only the pure evaporated distilled steam is going up into the condenser, getting cooled, and then it is filling up this pot. Change of color. filling up this pot over here. This is your fresh water, produced fresh water. Okay, now important part is the brine ejection, how it is happening, because there is no point of this freshwater generator if your vacuum is not maintained. So first is this air vent. Air vent should be shut. Air vent should be shut. On the top there is a temperature gauge over here that is showing the cell temperature. This is your vacuum gauge, okay, showing the vacuum, and this is a relief valve as in the previous design also it was there. Now this is the brine induction line. This is the line for air ejection from the condenser part. So this one is a non-return valve that was there also, because if there is no non-return valve, there will be a tendency, if there is reverse pressure, this can go inside air can be going inside there. Okay, so it's a non always swing check valve. You can see this is a swing check valve. If you are not able to locate, this is the swing check valve over here written. Okay, swing check valve is this. From here the air, and this is called a vacuum adjusting valve. Later on when we study, we can see by adjusting this, the amount of vacuum can be reduced or increased by this. Okay, so sometimes it's a very cold climate and you want the vacuum to be, say it is going very 90-95%, you want it to be moderate. Why? Because if the vacuum is 95%, your salinity will be very high. Salt will be carried over and salt will get condensed and it will go into the freshwater line. Okay, so to control the salinity, you reduce the vacuum also. This is called a vacuum adjusting valve over here in the line. So just like a ball valve over here, and this is the ejector. So through this the air is ejected, and this is the brine ejection line. Brine ejection, this is air. This is also a swing check non-return valve type. You can see this is the brine ejection. From here the ejection is happening, and after the ejection, okay, this is going through this line, okay, to the condenser, and from there it is going overboard. So overboard line is this common through the condenser. So brine and air, everything is passing through this line, condenser line, and then going overboard. Okay, come to freshwater production. So this is my freshwater production line. From here you can see this is a sight glass given ki how much water is actually maintained. So this sight glass should not be filled. That means your pump is not able to pump. It should be around empty, or a very little quantity should be there. And this is going to your distillate pump line. Okay, here is your distillate pump. This is your chemical supply line. Okay, this is the distillate pump, freshwater pump. Here you have got a compound gauge, so show that the pressure is not negative. If negative, that means there is no suction, the pump is running dry. Okay, so the pressure should always be positive here. This line is actually given to fill water. So as in the previous case it was coming from hydrophore, they have given one line to fill water in this chemical tank. This is there is a small pump also installed, so pump will be able to pump in the metering amount of chemical. So this pump runs on the power supply, small pump, magnetic pump. Okay, through the distillate pump, it's a normal valve, globe valve, passed to the salinometer. This SC is your salinometer or salinity cell, as it is called over here, salinometer. So salinometer, here it is one thing important to note. Through the salinometer, when the salinity increase, so this is giving salinity to the salinity indicator, supplied to the salinity indicator. There is an alarm and there is a power supply connected to the board over here. So salinity value is transmitted over here. Say alarm is coming, then this there is a solenoid valve here, over here. S stands for solenoid valve. Just SPV. So it was shown over here somewhere. So this stands for actually solenoid valve. So this solenoid valve will be electrically operated. Spring loaded and electrically operated. So as the alarm will come, this solenoid will open. This solenoid will open and this will open this path. This path will open. This path. And water will not go into this line. This is the swing check valve, non-return valve, so that there is no from the tank side, no water should come into this. Say pump has lost suction, so water should not flow from back side. That is why there is a head also, 18-meter head. So 18-meter head is 1.8 bar back pressure is always acting on the distillate pump, so that the pump can overcome this back pressure and then supply water. Okay, to keep the positive suction head on the pump. Then why? Now the question is why it will go through this line. So you can see if this LNT rises, this solenoid valve will open and water will pass on from this line and go inside the shell over here, where it will be extracted by the brine. Okay, this line, it will go inside the shell, and from there the brine will extract it. It will be extracted by the elector. But why will we choose this line, not this line? So because it is, you have a back pressure over here, 1.8 bar acting, the pump will always find an easy path to go, easy path to pump the water. So when this solenoid will open, the easiest path for the water will be this one, because there is no back pressure. This line is already, this line is having vacuum because there is this connection. So this is already trying to suck in this or pull this water, no? So there is no back pressure also. So always this, when the salinity will be high, this indicator as this solenoid valve will open, this path will be preferred by the pump. So there it will go in this line. Important question, huh? Why you will follow this line, not this line? Because there is a back pressure plus there is a vacuum in this line to suck up. Okay. Then this is the three-way valve, both for the flow meters. So if the flow meter is working, you need to work to pass through this. This valve line should be open. If the flow meter is not working, open this line and bypass the solenoid valve. This is the back pressure, and then the water goes into the freshwater tank. Okay, so I think I have covered almost everything that is in this diagram for you to understand. Okay, there is this is the vacuum breaker over here. So if you want to break vacuum for the condenser plant, the vacuum breaker is this one. Okay. So these ones are the valves as indicated in the diagram, and so is the diagram explained to you in this case. So this is the most important part to understand. If you understand this, you can understand the working of this Sasakura type shell and tube type of freshwater generator. Okay, thank you guys.